welcome to my presentation. I'm a PhD student from Norwegian University of Science and Technology. I'm going to present the research conducted by me, Kira, Luisa, and Marius. The research is titled Learning Pairwise Interaction for Generalizable DeepFake Detection. First, I will introduce the background or the motivation of this paper and the deepfake detection. So, deepfake are synthetic media and they are generated by deep learning methods. So, basically, they are manipulated images and videos. Our goal is to detect deepfake in order to prevent malicious propaganda, and generalization is a big obstacle to the deepfake detection now, because networks tend to overfit on the training data. So their performance drops dramatically when they are used to test unknown deepfake. And the third one is pairwise interaction. One can easily discover contrastive cues from a pair of images so that distinguish them by pairwise interaction. Pairwise interaction is introduced in this paper called Learning Attentive Pairwise Interaction for Fine-Grained Classification. So our contribution of this paper is that we proposed a new framework called multi-channel exception attentive pairwise interaction, and we report all the results with balanced open set classification accuracy. This BOSC accuracy is used to amplify the generalizability of our proposed approach. And we conducted a cross-data validation on the three state-of-the-art deepfake dataset, which are CelebDF, KODF, and the fake AV. Furthermore, we provide a detailed explainable analysis using t-SNE and activation maps. So this is the architecture of the MCX API. We first utilized MTCAN to crop and align the face region of a single frame. So, and then two selected images are then sent to the multi-channel exception backbone. For the multi-channel, we mean that instead of using only RGB image, which is 3 channels, we use n different channels, including CIE lab, HSV, and YCBCR, addition to RGB. The features extracted by the backbone then are sent to create pairwise interactions for further classification. So for the experiments, we first conduct the intra-dataset evaluation. We train our proposed network on the Face Forensics C23 dataset. We test the performance on the test data in a non-overlapping manner regarding the identification. We can see from this table that our proposed Max API network with RGB inputs reaches the highest average accuracy, which is 98.48%. In addition, this setting also gains the highest accuracy on awful manipulation with 98.75%, 99.90%, 98.5%, and 96.75%. We also noticed that this network gains improvement on the ACU score when YCBCR is introduced. The API is the original pairwise interaction network here, which use ResNet 101 as a backbone. With the substitution of multi-channel exception, we can see that the performance has been greatly improved. We further compare the performance with the state-of-the-art networks. Here, all the networks are trained and tested on Face Forensics C23. Our Max API network obtained the best performance with both accuracy and AUC score, which is 98.48% and 0.9968. The result shows that our idea of pairwise learning in a fine-grained manner could work well in inter-class setting of deepfake detection problem. And then we conduct experiments on 3 other datasets, celebrity DF, fake AV, and KODF. Also, we compare the results with the state-of-the-art deepfake detection methods. Here, also all the networks are trained on Face Forensics C23. Max API with RGB plus CIE Lab achieves the best scores for KODF here with 81.16% accuracy and 0.90 AUC score. And Max API with YCBCR achieves the best cross-data validation accuracy on the celebrity DF with 90.87% accuracy and the second best AUC score of 0.90. And API net with color space RGB plus HSV plus CIE Lab and achieves the second best place for fake AV with 92.38 accuracy and 0.98 AUC score. For the experimental analysis, we first utilize the t-SNE for the features. The figure on the left is the t-SNE for Max API, and on the figure on the right is for the original API network using ResNet 101 as the backbone. We can see that the Max API obtains clear boundaries among 5 classes compared to the API net, but there are still places with misclassification. For example, real vs neural textures, which is shown here, and real vs face swap, which is shown here. We then applied the 5 different activation visualization methods, and we blow up one of them called layer cam to show the results we can see. For example, here under the eyebrow, there are inconsistency pixels, and the Max API paid much more attention around this area. And here inside the mouth, we can also see there exists inconsistency, and our Max API net give more attention compared to the API net. Talk a little about the limitation and future work of this paper. We noticed in the intra-set experiments that with the increase in the color spaces, there are actually no apparent improvements in the accuracy. We assume that there is actually redundant information among channels. So the further work would be focused on finding the most helpful color information to extend our proposed approach. We also observe that no single configuration could perform reasonably well for all the unseen data. And this is the biggest issue for DeepFake detection tasks. So introducing other information such as temporal data and audio would be a good idea, as more inconsistency could be found by extending our work to the video-based approach. Yeah, thank you.